guys, and welcome back to Math Woman. You are in the right place if you're looking for quick and easy math, brain training, mental math, and also a little bit of fun. I hope you enjoyed the song you reviewed at the top of your lungs. If you didn't, maybe you missed something. But now let's go because special encounters waits even in rational number world. So let's go. And here is my first encounter, complementary fraction. Even if the name is quite ugly, the idea is even kind of romantic. Why? If we have one fraction, we are looking for another one which combined with it to form the whole one. So they complete each other. It's also a little bit of romantic. In a drawing, if I have a fraction 5 over 6, the whole divided in 6 parts and 5 shaded, I'm looking for the missing part. In my drawing, the white part, 1 over 6. Just if my starting fraction is 2 over 3, I'm looking for 1 over 3 to reach 1. If I'm looking for the complementary fraction of 1/2, I need 1/2. If I'm looking for the complementary fraction of 2 over 4, I need 2 over 4. I have to reach the number written in the denominator. So let's look at the example 2 over 7. I need 5 over 7 to reach 1. And now we have our second encounter, which is the equivalent fractions. Equivalent fractions are fractions written in different ways, but that actually value the same. They equals 1/2. With that example, it's so clear. If I have 1/2, whole one divided in 2 parts and only one shaded, I can have the same quantity if I take my whole one divided in 4 parts, but I take 2. Why the key is the invariant property? Because if I start from a fraction, I can have infinity equivalent fraction just multiplying by the same number the numerator and the denominator. So it's easy. Is there a way to write all the infinite equivalent fraction? Yes, there is for the same number, numerator and denominator. First by 2, then by 3, then by 4. To write this set, I have to use a capital letter because we use capital letter to indicate the different sets of numbers. In the brackets, I have to put the fraction written with the smallest number which is possible. And then after the equal in other brackets, I have to put all my equivalent fraction divided by a comma. If we can multiply by the same number, numerator and denominator, we can also divide by the same number, numerator and denominator. In this way, we get the simplest equivalent fraction. Now, let's simplify. This is another way we can name this proceeding. Okay, 6 over 2 is the number 3. We can write it as 3 over 1 or simply by the natural number 3 because 6 divided by 2 equals to 3. Let's simplify 15 over 6. We can divide numerator and denominator by 3. So it equals 5 over 2 because 15 divided by 3 is 5 and 6 divided by 3 is 2. Let's simplify also 28 divided 14. It is the number 2 because 28 divided by 14 equals to 2. And now what me transform you? Yes, we can divide or multiply both the numerator and the denominator by the same number to get an equivalent fraction, but written as I like, because we are in charge, we have the power to decide how to write our fraction. So, for example, if my starting fraction is 6 over 8 and I wanted to write it with a new denominator, with 42, I can use invariant property. A to become 32 has to be multiplied by 4. So even 6 is to be multiplied by 4. But how can I do if I can't solve it in my mind? Well, the first thing you have to do is divide the new denominator by the original one, which is 8. So 32 divided by 8 equals to 4. So I know I have to use the number 4 to multiply both the numerator and the denominator. And it's your turn. Let's see what you can do. I prepared some simple exercise so you can verify if you understood this lesson. If not, give it another try. What is the complementary fraction of 6 over 8? 2 over 8, because I need 2 more parts to reach 8 over 8. What is the complementary fraction of 11 over 15? 4 over 15, because I need 4 over 15 to reach 15 over 15 if my starting fraction is 11 over 15. What is the simplified fraction? 3 over 4, because both 6 and 8 can be divided by 2. What is the fraction in lowest term? 7 over 6. Both 28 and 24 can be divided by 4. So 28 divided by 4 is 7. 24 divided by 4 is 6. Can you find the equivalent fraction? Well, if 4 is multiplied by 9 to become 46, then 5 has to be multiplied by 9 and it becomes 45. Can you find the equivalent fraction? If 6 is multiplied by 6 to become 46, then 7 has to be multiplied by 6 and it becomes 42. And now we go with our musical part. I hope you will enjoy this new song. So let's dance together.
Sometimes a special encounter happens, even in the world of irrational numbers. Sometimes equivalent, sometimes complementary, but always so special eventually. If I am 1/2 and you are 2/4, just walk back and forth. Our value is the same, even if we look different. Tell me, do you see? We are equivalent, united by a law in this infinity. You'll find us with the invariant property. Sometimes a special encounter happens, even in the world of rational numbers. Sometimes equivalent, sometimes complementary, but always so special eventually. If I am 1/3 and you are 2/3, we're different but not enemy. Together we form a whole one. Complementary, we found each other. We're not equal, but we complete one another. Two rationals that